Hey guys, welcome to Programmer Polyglot, the podcast where we explore the wide range of programming languages and how they come together to solve real-world problems. I'm your host Kalyana Sundaram K, and today we are diving into a fascinating project that combines computer vision and Python to detect suspicious activities in a video footage. Whether you are a Python enthusiast, a computer vision researcher, or someone curious about the intersection of AI and security, this episode has something for you. Let's start with segment 1. Why suspicious activity detection is needed. Let's start by asking why suspicious activity detection is such an important topic today. With the proliferation of surveillance cameras in public spaces, malls, airports, and even in smart homes, there is a growing demand for automated systems to help monitor and analyze video feeds. Imagine the countless hours of footage being recorded every day. Reviewing it all manually is not only a time-consuming process but inefficient. That's where AI-driven video analysis comes in. By using computer vision algorithms, we can automatically flag potential threats or suspicious movement and helping to prevent the incidents before they escalate. But how does it all work? And more specifically, how Python helps us achieve it. Okay, let's get started to segment 2, where we are going to concentrate on Python and OpenCV, a perfect match. Python, with its rich ecosystem of libraries and modules, has become go-to language for AI and machine learning projects, and even in data science. One of the most powerful tools in our arsenal is OpenCV, an open source library for computer vision tasks, and OpenCV makes it is an incredible process to work with images and videos, and its integration with Python provides a user-friendly way to develop a real-time video analysis applications. In this particular project, we focus on detecting motions from CCTV footages. Think of it as a first step in identifying the suspicious activities through the CCTV footages. Our system can detect any kind of movement, isolate the objects of interest, and track them as they move across the scene. Let's start with the example code. The first thing with Python, you want to import two things. One is OpenCV library and iModels library, where import CV2 and import iModels. And let's start the video footage. First, you want to load the video footage. Video equal to cv2.video capture, and the CCTV footage path or the direct path you want to enter here. Let's subtract the background, that is removing the background by detecting it. Background subtractor is equal to cv2.create background subtractor emoj2 detects shadows is equal to 2. Let's set a while loop here to run again and again. Create a frame, and if there is not a frame, break it. Then frame is equal to iModels of resize, and create a foreground mask which will be applying as a second frame. Then create a threshold screen. Totally you got three screens, which will be the detection screen and the foreground mask and the threshold screen. The contrast will be detected here, and run a contrast to create box like detections to detect the suspicious activities, and show the image through CV2, which is OpenCV, as suspicious detection in the frame, and hereby release the video and destroy all the windows for the efficient memory use. This is a simple code that allows you to capture the video frames, apply background subtraction to detect motion, and highlights areas of potential interest in real time. And the best part is, it's all in Python. Here comes the segment 3, real world applications. So what does it all mean as a practical sense? Well, systems like this can be used in variety of settings. One is security surveillance, home automation, retail analytics, and more on. And this is just the beginning. You could extend the system not only to detect the movement but also classify it like weapon detection, like theft detection, using machine learning models to differentiate between normal and suspicious activities. Now, segment 4, enhancing the system with machine learning. Now, take the step further. You can integrate machine learning into this project. For instance, you can use a conventional neural network, which is CNN, which is an AI machine learning algorithm, to classify detected movements. Is someone running through an airport carrying luggage, or they are moving suspiciously without any context, like wearing a mask and wearing a hoodie, which is a suspicious activities. You can detect it and train the training images or a video to an old model. The person will be detecting as suspicious, reducing the false alarms and increasing the accuracy. Additionally, you might want to explore OpenPose for human pose detection or MediaPipe for human pose detections. which can recognize the specific actions like falling, running, loitering. The possibilities of improvements are endless. The future of automated security is segment 5. With the rapid advancement in AI and computer vision, the future of automated security looks incredibly promising. From preventing crime to offer real-time alerts for potential threats, Python and OpenCV are enabling developers to build innovative solutions for modern challenges. But there is always a balance to strike. While technology can enhance security, we will also need to privacy concerns. The rise of AI surveillance brings with a host of ethical discussions. Once we will deep deeper into a future episode. That's all for today's episode of Programmer Polyglot. We have barely scratched the surface of suspicious activity detection using Python, CV, and AI-driven video analysis. If you are interested in experimenting the code yourself, you can find the complete project and more resources in the show notes. If you enjoyed the episode, be sure to subscribe and leave us a review and let us know what other topics you are interested in. Until next time, I'm your host Kalyana Sundaram K signing off. Thank you.